So the purpose of this code for lab 4 is to use the encoder sensors instead of timing like in the previous labs to drive the robot. So with encoders, the goal is to drive the robot straight for 100 centimeters, stop for 2 seconds, then drive it backwards for 100 centimeters in a straight line, similar to the previous lab, lab 2. So the standard Rumi motor, they have a gear ratio of 120, around 120 to 1. So that's 12 counts per revolution. So one revolution of a Rumi wheel is 1,437. So over here I have the class members, and then the magic numbers over here, just defining my wheel diameter, and then the encoder pulses, and then the distance that I set for the robot to travel. So I'm over here my speed of the motors. My left speed I have at 47, right speed at 41. Slow and steady. Have my left speed set at 47 because my left speed is weaker than my right. So yeah. Then over here voice setup. Serial begin 9600 baud rate for the serial monitor. Then over here I have my loop function. So this function, the meat and potatoes, is to drive, stop, reverse. Contains the button press too. So at first, I have my button press. If button A is pressed, there's a 2-second delay. And then I have these variables. Count distance. So that the distance that the robot needs to travel is, I guess, converted into a way that the robot understands. So count left, count right. This is just to reset the encoders. The encoder counts to 0 to provide more of an accurate measurement for when they start. So this is for the robot to drive forward. And then I have this while loop. So while the left and right count for the encoders are less than the number of pulses needed, then the counts are stored. And then I have over here the stop, the motor speed stop motor to stop the robot and delay for 2 seconds before it reverses. So then I have my robot reversing here. So similar to above, have my left and right encoder counts. And then over here, my set speeds, I have negative numbers because it's going in reverse. So my left speed, like I said, my left speed is my left motor is weaker than my right, so I'll put a -1 over here to kind of balance it. And then I have another while loop. So while the right and left encoder counts are greater than the negative number of pulses, then it stores the encoder counts. So that it reverses, and then over here it stops. Then 2 seconds, and then it delays. It waits forever, and then waits for the button count. Then over here, this function is count for distance, just to convert, similar to what I said above here, just to convert the distance to a value that the robot can read. So I have my Rumi robot over here, about to upload the code. So I have over here my setup. I'm gonna put the Rumi tire right at the top. Okay, so I have my setup. Tape measurement is out for the black tape. As you can see, 1 centimeter. Have 100 centimeters measured out. So now I'm gonna press button A. So if I measure it out, well, I'll just start it again. To show that every time I press button A, it loops. So forward it drives pretty straight, but backwards it's a little off. So where my foot is where I had the robot start. So right here. Which is about right here. So I had the robot right here. So this is about maybe 10 centimeters from the start point, and it's off for the reverse.